and I got my journey in education start from Universitas Brawijaya from Malang. I got my bachelor degree in industrial engineering and then my master degree in supply chain management of industrial engineering, because in ITS, or we call Institute Technology 10 November, there Department Industrial Engineering and 5 branch knowledge there, and one of it is logistic and supply chain, and I took that course. And in the 2019, I got certified as supply chain analyst, supply chain certification from the International Supply Chain Education Alliance. I think that's the first time we met, right, Pak Wira? And in the certification from ESGA. And then I got also decide that I really interesting about this topic, and then I want to further enhance my knowledge and my skills in this field. So I got a second certification for professional in logistic management, supply chain certification from the International Supply Chain Education Alliance also in 2021. And then I decide my career become a lecturer, and in the 2020 I work as a lecturer at logistical engineering at Universitas Pertamina. And in the also in the 2020 I got discussion with Pak Wira. We have a same vision about that industrial and academia, it's need each other, it's have to complement each other. So we decide to create some community that we call Check Info Logistic. We try to bridge the relationship between industrial and the academia, because academia needs some insight also from perspective of industrial, and industrial needs some information about the development of knowledge, theoretical, and anything aspect related to the field. And okay, Sam. And because some of circumstance, Pak Wira decide to move the next step of his career, and then he joined Binus, right, Pak Wira, and then I got some responsibility from him. I'm become head of distribution system laboratory at Logistic Engineering Universitas Pertama also in 2020. There's a very fast event for me for those years. Okay, for the project, I start project from my master degree in 2019. I become a agent-based simulation. Yeah, one of topic from my supervisor there. I create an agent-based simulation for market simulation. I try to identify, and then I try to analyze how the retail and customer build a relationship between them, how the strategy retail affect the customers and vice versa. And then I realized that supply chain is very big. It start from, if you already, I don't know if you took a class supply chain or logistic or anything, but the concept of logistic and supply chain, it's very similar. We are try to provide what customer demand. So I think that I have to enhance my skill and further study in consumer behavior, because if you want to create a good strategy in supply chain, first of all, I have to make sure that my strategy is fit with what customer demands. So I think that I need to learn about customer behavior more. So I took a project in 2020, and then um further next year in 2021, I found that's a very interesting topic about circular economy, because right now there's our concern, right, about environment, about how the business still running and incorporate the aspect of sustainability. So that I took my next project and my next focus in circular economy in supply chain and logistics. And I also collaborate with a startup in Indonesia named Cyclus to learn, study how they are growth, how they are designed, how their business running, and then what aspect of logistic and supply chain that I can give them and provide information for their growth. And then up until now, I still have some project with some of startup in Indonesia, especially in concern for area of circular economy and supply chain management. But I also give some consultancy for startup in their early stage, how they are make strategy in supply chain, production plan, procurement, how they are pick supplier, how they are make the inventory control or anything related with this logistic and supply chain field. Yeah, then that's give me more drive and motivation to learn more about this field. And happily today I could share some aspect in supply chain that will be make you interest. Yeah, I have some research, more of most of it collaboration with Wira here. You could find the title in Google Scholar and anything. So this is what I'm working right now most of the time. Up here, this is example some of my my project facility location, most of it using Anylogistix today. I'm gonna show you how this tools works. Facility location is part of my research interest, network optimization, and then also a simulation. If you the introduction first from Mr. Wira, Pak Wira said that this tool is powerful tool to optimize not only the discrete optimization, but some of it we can use for stochastic, because we can incorporate simulation here and then we can combine it. Yeah. After we found the optimization, we can move it into the simulation. After we try in simulation how resilience our model develop with our data and scenario, how impact of the real dynamic like change in time or anything. And we found it, we need it to be more optimized. We can move it again into the optimization aspect in the analysis. That's make this tools very flexible. It's very easy to build the model in here. There is math modeling, but it's not the mind part when you create the model. Yeah, you can only create the scenario, and then the math modeling will be it's part of the tools. There will be it create and develop it. We don't focus on that, but we need to sharp our sense in analyze in aspect of supply chain and logistic and how optimize it. There's our part here. And then also about transportation optimization, about the simulation of logistic and supply chain, also from strategical perspective, tactical perspective. about operational perspective, that are my research interests. I also have some project right now with my students in Indonesia that we create, we try to analyze the capacity and workload balance using Anylogistix software. Also about, we try to analyze the inventory policy using Anylogistix. I'm sorry. And also like I told you before, I'm really interested in consumer behavior because it's the 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 most important things. So I like to study and do some research using some theoretical in consumer behavior with the vision of innovation, with theoretical theory of planned behavior. And I also like to implement that to create some agent-based simulation to identify the relationship between agent, between the supply chain, between the part of the supply chain with the customer, also the relationship between each part between the supply chain. And then analyzes impact of consumer behavior to the logistic aspect with the structural equation model. So my skill is related with supply chain management, logistic, and supplier selection, network optimization, transportation optimization, production plan, inventory control, tools, the Anylogistix, IBM Net logo, PLSMs using smart PLS, and then yeah, SPSS and anything. This is my thesis at my master degree, the agent-based simulation, and this sum of works using structural equation model. Okay, I think that's all from my side for introduction. If you have a question or have an interest, I'm very open to discuss about especially topic in logistic and supply chain. You're gonna discuss anything. You want to ask something, just ask. Maybe Mr. Rivera can share my contact. You can email me. You can we can connect in LinkedIn also. So yeah. I think it's there for the next step. But for today, I have to give a thank you for warm welcome. And then in this weekend, you spend your time to study more about this topic. I really appreciate it. That what of topic that I want to share today is part of supply chain. We will try to design the network in the supply chain. All right, using Anylogistix software. Maybe there's will be a little tutorial or demo for me. I will show you how to build a simple model. All the resources, you can download it from the website. It's open source. You can also download the software right now. Maybe we can do tutorial together. So first of all, I will start with the concept. We have plenty of time. Maybe I will try to explain first about the concept today. Supply chain network design is a consists of the location analysis framework for selecting location of source, production, and storage facility, as well as incorporating the connection between them into the overall supply chain. So it depends on the condition of the real case. Maybe the industry, if I can take an example, they are in the early state of their business. They know the location of their consumer, but they don't know where the facility for distribution center or for the retail to build, and how to connect those new facility with the existing facility with their supplier, with their main supplier, and how to make the connection. That is mostly part of what we call it network design. So in this today, I can say in this today class, we're gonna make sure we are connecting, we are decide the connection between like supplier here will be feeding which manufacturer, and manufacturer which will feed a distributor, retail, and an end customer. But how the connection will be, each stage will be made. Maybe supplier one will be like this, will be feed the manufacturer two. Maybe supplier one could also feed the manufacturer one, right? And also maybe supplier one only feed the manufacturer one. It's all depends on the constraint that we're gonna discuss today. The constraint is, first, we already talk about is what role should each facility play, what process are performed at each facility. We have to decide that manufacturer to production, distributor maybe for brick bulk, and inventory retail mostly to market our product to customer. Where should the facility location, and then how much? Yeah, this is will be affect our decision. The capacity manufacturer we have to decide how much capacity maximum that manufacturer one can do their job, yeah, to production. How many capacity supplier that we are order from them. It will be affect the connection. If this has a more capacity and can provide like two manufacturer, we could make a connection here, right? But when it has a limitation capacity, maybe it's only one manufacturer, and then we have to decide also which manufacturer that the supplier have to fit in the next production cycle. Okay, and then what market should each facility serve, and which supply source should fit its facility? This 4 question mostly that we're gonna running through until the demo session about the network design. Yeah. For another example, this is our case study today. You could see there is a customer customer from Bremen, Cologne, Frankfurt, and Stuttgart. Here we have a 2 distribution center from the potential distribution center from Czech Republic and Stemohagen, and then we also have a manufacturer from Poland and Nuremberg, and we have an 8 supplier that supply those existing factory. But now we have to decide the connection. At the end of this class, you will have a connection, which factory that will be still open and which factory that we decide to close, or we decide to open both factory, and then which connection that will be made between this factory and distribution center. All of that in one tutorial today. So we have an option here. This is the decision alternative that manager of logistics and supply chain have to decide. And as an academia, this is our part to guide them, to give them the alternative, to give them explanation for each alternative, what trade-off in each alternative, so they can make a good decision, a confident decision. For me, what is the characteristic of a good decision is when you're confident to make a decision. And to be confident, you need a lot of information, you need a lot of data, you have to make sure that you cover every possible problem, and then you have an alternative solution for that, and then you become confident. because every solution maybe have an negative impact. I think there's a very naive when we say that there are a perfect solution for anything, because every problem has their constraint. Every problem, maybe we approach them with the assumption and limitation. But for me, what made a good decision, if you confident enough to take, okay, I want to use road one, I want to use the option one, because this option have uh very limited, a very less negative impact, and also have a solution for what the further had, for the negative impact. That's it. When I think a good decision has been made, and to help the industry, that's our part as academia, to help and guide them and give the 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 option, and then explain them for every situation. All right, that's the concept today. If you have a question, just raise hand and we can discuss, because I'm still early in this my career, just 3 years as lecturer. So I don't like to be, I really like to say this as sharing, so we can discuss more about this. You have anything you want to ask, just ask me. Okay. Next, what is role and what's impact of the network distribution to supply chain performance? The network decision have a significant impact on the performance of supply chain, and the performance supply chain for all the aspect, right, in the sustainable business of the firm and company, their financial aspect, their operational aspect. Because when you decide to create a network in supply chain, it will be determined the configuration of the supply chain, right? You will be decide, maybe I don't need retail. Maybe I will stick with only supplier, manufacturer, and distribution center. And after distribution center, I will use a direct shipment to customers. There's one of things that you have to decide, because we talk about it, what a role should each facility, and it will be impact the configuration. You have a long stage in supply chain, or just short stage, like I said before, and it will be set constraints within each other supply chain drivers. This is drivers that will be talked. It's about how the facility going, their role for each part in supply chain, how the inventory policy, how the inventory management in their supply chain works, and how we decide about this transportation policy, what mode that we are going to use in to transport our product from for each stage in supply chain. It will be also affected, and how we are going to create our system information here, right? How we're gonna use the sourcing, or make a connection between each stage, and how we are gonna decide the pricing, because the operational aspect and financial aspect will be affect our decision in pricing. So the role of network design will be determine our supply chain configuration, and also it will be affect our activity below in drivers of supply chain from perspective of logistical drivers and cross-functional drivers. So you have to make sure that you have to really careful calculate it, okay? And then it will be maybe decrease supply chain costs. It has an opportunity to decrease supply chain costs or to increase the responsiveness of your supply chain. How you are, if you are make a good supply chain network, it will be, maybe it will be speed up your process to distribute your product to the customer. You maybe have a possibility to be have a good recovery system when a recovery process when you're make mistakes because your configuration have a provide that, and then also you could have a flexibility enough to satisfy your customers. And then also a good decision maybe with all the alternative also in the financial perspective will be have an opportunity to decrease the cost. All right. And then allocating too much capacity to location results in poor utilization, and as a result will be higher costs. If you didn't consider this network design as your main focus, it will be affect in this situation. Maybe you will be allocating too much capacity, and then maybe you have a poor utilization and you have a higher cost, or you will be have another condition. Allocating too little capacity result in poor responsiveness if demand is not satisfied. It's another condition that will be happen if you don't focus enough on create a good network design. Okay, all of that will be impact the performance because it affect a total production, inventory, and transportation costs incurred by the supply chain to satisfy customers' demand. Okay, that's the role of network design, and then maybe some significant impact on the performance of supply chain. Okay, you have a question here? Okay, if there's no question yet, I will continue. Okay, we already know the concept of network design, and then we already know the role of network design, also their impact and the supply chain performance here. Next is the framework to design decision for network design. There's 4 phases. Maybe the 1, 2, and 3 phase is something top management will be decided, but today we're gonna focus for the tutorial in the phase 4, how to pick the location and create the network design, and maybe use simulation to check our network design if still it's resilient enough, or we have maybe have to make adjustment, or we have to pick a good policy to support our decision when we are already created the network design. Okay, but I will gonna explain it step by step. Yeah, from the phase 1, phase 2, phase 3 until the phase 4. Mostly the phase 1 is about the discussion in top management, what the competitive strategy, internal concern, or anything, the global competition that will be affected. And then after that, we decide, okay, this is our strategy, this is our supply chain strategy, the regional or the possibility of option we have will be reduced to the most sweet with the fit with our strategy. In the phase 2, we discuss about political, tariff, tax, competition, improvement, and anything that to reduce also about our option. And then up until that we decide this regional is the best location to create our facility, and then we are start calculating there. Okay. Start from the phase one, define a supply chain strategy and design. The objective of the first phase of network design is to define firm's broad supply chain design. This includes determining the stage in the supply chain and whether each supply chain function will be performed in-house or outsourced. So mostly it's about the supply chain strategy. What is strategy that we have decided? It's very important because the supply chain strategy will be direct all the drivers below it. Okay, to make a good supply chain strategy, you have to understand first your customer, because we need a strategy fit enough to satisfy their needs. And then when you are trying to make a network design, this is the first thing you have to understand. You build your own company, or you're working to another organization, firms, or company, you have to understand first, or maybe you made a decision what supply chain strategy that we are going to pursue in the next 3 or 5 years. You want to become efficient because you have the limited budget or capital, or you want to have an unlimited budget and capital, that you are pursue the responsiveness, you pursue the speed, you pursue the recovery, you pursue the flexibility. And it will be decided if you pursue the the responsiveness. Maybe you will make a many facility, because the many facility could be it will make the product more available, right, in the market. Yeah, I talk about maybe you could make a lot of retail in the regional, so it will be responsive for your customer. If there is no if your customer could find the product in the retail one, retail two can provide a recovery with flexibility, your availability level, it will be high, and we could say that responsiveness will be high. And if you decide responsive, maybe you will build your inventory level to the service level that have a lot of safety stock in them. So it will be give a good availability level and responsiveness, because your customer will be not you will be always have their needs satisfied or anything. But if you decide using a vision strategy, maybe you have to really careful when you are decide to build your next facility. This will be at the cost or not, how many this will be affect the cost structure or anything. Inventory also, you will be very careful to decide the set level of your inventory. If it higher enough, it will be affect your cost structure also. So that's an example how the supply chain strategy will be affect your direction in the create the all drivers, and also about the network design. So this is first is the top management level that have to decide what kind of the supply chain strategy they want to push, right? It could be you, or it could be a top management in company you work. But you have to understand this first, okay? Because it has to be aligned. You couldn't create a very efficient, but the strategy is responsive. It will be opposite, and then it will be counterproductive with the result, I think. Okay. So the phase one is start a clear definition of firm's competitive strategy, and then set customer needs, the supply chain aims to satisfy. Okay. And then it will be specify the supply chain strategy. And then in there, we have to make a great compatibility with the supply chain network and the supply chain strategy, like I told before. Okay, this is the first one, the phase one, sorry. You have a competitive strategy. To have a consider here, you have an internal constraint, maybe the capital, the growth strategy, the existing network that you have to decide, and will be affect what kind of strategy that you have choose. And then you also have the global competition. Okay, you have a global competition to consider here. And decide, okay, we have our supply static here as a result. Next, we move into the phase 2. In the phase 2, we are trying to define regional facility and configuration. The objective of the second phase of network design is to identify region where facility will be located, their potential roles, and their approximate capacity. For example, in the Philippines, in this context, Philippines, Indonesia, if I try to serve a market in the Philippines and I'm company from Indonesia, and then I pursue responsive strategy in this example, maybe it's better for me to decide a Philippines as my regional to create my facility because it will be both my responsiveness ability to serve the market, right? But it's not only that, we have to consider another things like tariff and taxes incentive in our regional that we are designing. So in this context is in the Philippines, I have to calculate the tariff, tax, this incentive. I have to understand the regional demand, size, growth, specification. Can I provide that? I have that. Do I have an ability to provide the changing, the evolution, the evolution of the market, the growth of the market, right? Also about the political demand risk in there. It's a company from Indonesia that have a legal Indonesia, have some or between the two countries have a political issue or anything. I have to consider also about that, about the product and technologies that I want to implement in facility. There's a regional can support it or not. And then how about the competitive environment? There is a barrier to penetrate. It's very hard or it's easy to penetrate the barrier. I have to consider it also. And then about the logistical costs. Maybe some of my raw material is still from Indonesia. So it's a better because I want to pursue responsiveness to create my facility in the Philippines, or I stay in Indonesia and then just start distributed, export it from Indonesia. Right. We have a consider here from the strategy. I want to pursue responsiveness, but next I just cannot then decide, okay, let's go. We are we are all out using our resource to achieve that without next considering about the phase 2, the configuration, the regional facility. Okay, so it will be given direction, but we still have to very careful here to to calculate our decision, because it's this methodological, it has a steps in there, is a phase in there. I think it will be more beneficial that we are consider all the phase before I make a decision, a final decision. Okay, in the phase 2 we already discussed it, and next in the phase 3 we are trying to it's maybe a little bit similar with the phase 2. Select set of desirable potential site. Maybe in the region we decide, okay, after we are consider all the other aspect in the phase 2, we still decide to build our facility, production facility, manufacturing facility in Philippines. But which side of Philippines, which area of Philippines that we decide to build our manufacture? There's a next phase that we have to decide. We have to we have to consider about the production method, skill needs, the response time, the production time, or anything. And then we have to make sure there is an available infrastructure to support our decision here, which part of the Philippines that suit our our desire, it will be the best option there. Maybe there is an industrial area in there that provide and have a very good infrastructure. Okay, and then maybe there's some area that could help us provide some support in aspect of our facility and our performance in logistics and supply chain. Okay, soft infrastructure requirement also include the availability of skilled workforce turnover, and community receptivity to business and industry. Because yeah, we have to make sure that in the region there is a lot of skilled labor, and then we have to pay very respectful from them, and then they have a very good life to be perform better in our facility. So you have to consider about it also about workforce. Okay, and then we are moved to the next phase, and the last phase or phase 4. This is the location choice. The objective of the phase 4 is to select from among the potential site a precise location and capacity allocation for each facility. This is when we are using Anylogistix to help us more about the decision process, right? In the phase 4, most of it will be about the cost, about the logistical costs, about transportation, inventory, and about the coordination between each stage, about labor materials, and site specific. In this, will be use some tools in Anylogistix. We are start from the location allocation problem using GFA. It's if you are already know, maybe it's similar with center gravity algorithm. And then after that, we use the facility location to create network optimization in Anylogistix, and maybe we'll do some simulation. We're gonna see how the resilience our supply chain works. Okay. Okay, but before that, I will explain about Anylogistix tools. You have a question here because we are already done with the concept. Okay. No. Okay. If there's no question, I will give a little bit explanation about this software. You could download it. It's open source. Maybe I'm sorry. There is maybe different feature, not different feature. What we said. Maybe there's different kind of software that they provide. There is personal learning edition. There's free software, but in the studio and studio version you have to pay it. Maybe the university can pay it so that you could use a full version or full feature of the software. But personal learning edition is a very good software that you could use to enhance your skills and knowledge in supply chain management. So Anylogistix, we're back to the topic. Anylogistix is the supply chain analytics software to design, optimize, and analyze your company's supply chains. It combines powerful analytical optimization approach together with innovation simulation technologies, offering you comprehensive set of tools for end-to-end supply chains analytics. So it will be have a two big feature in there, the optimization, the disk and stochastic optimization, also about the simulation. Okay. Okay, what can we do in Anylogistix? I got it from their source there. Modeling logic with Anylogistix. First of all, you have to create scenarios. This scenarios is it's from the empirical study, it's from your observation, it's from your real case data. You have to create the scenario. How many customers that you want to serve? Okay, do you have an existing facility that already met? You have a factory, where's your suppliers, in what region that you want to create this model, and then how many mode of transportation that you already have, what kind of existing inventory policy, what of sourcing decision that your company using right now. There's all the scenarios that you have to build first that affect your model. Okay. And the next, you have a multi sub tools decision process that can help to make a good decision. You could use greenfield analysis, or this is particularly for location allocation problem. Like I said before, it's very similar with the center gravity algorithm. Or you could use analytical network optimization, network design, or you could use simulation. It depends on the scenario that you build and depends on your needs, what you want to solve, what kind of problem that you develop, what kind of problem you want to solve, what of result that you are looking for. And then you have a results, and then this result, like I said before, as an academia, it will be good for industrial to know all these options, all the option available, the alternative option available, which one is has a very good and a very good chance to enhance and for the sustainability aspect of a company. If I said about sustainability, it's not always about environmental sustainability. It's also about how the business growth, how we are getting more profit to help our company to grow. Okay. Okay. So what can we do in Anylogistix? First of all, facility location planning, center of gravity method for single and multiple location, network optimization using mixed linear programming, capacity planning of distribution center, inventory control policy and ordering rules, sourcing policy, single and multiple sourcing, transportation policy, full truckload or less than truckload, batching in transportation, production and sales. Or we could also check about our resilience, how resilient our decision in supply chain when it face the bullet effect and ripple effect in the supply chain. It will be happen in our real condition right now. There's a lot of ripple effect because of pandemic. Yeah, when it started in 2020, we could also create how good strategy for next possible pandemic when it happened for our supply chain. Prof. Dimitri Ivanov, he's very, very genius for my perspective, because it has a lot of published paper when pandemic happened. He researched a lot how the effect of pandemic and how to handle it, how to make strategy, how to decide when we are open. Is that open our facility, and then how to adjust when the regional regional force us to close our facility, how we are build our inventory to to make a good to make a resilient supply chain that we are could still satisfies the customer demand, even though the condition of pandemic happened. He published a lot. I think it's more than 20 journals that he published talk about the racial of supply chain. He also has a book focused on racial and supply chain. I really love read that, and anything here a solution that he provide to help the industry to make a good decision, because pandemic is something happen very spatial. It categorized as a spatial occurrence. The frequency occurrence is not often, but the impact to our performance in supply chain is very big. Okay, and then it will be force you to make a quick decision and accurate decision as possible. That's when academia have to help the industrial to make a quick and accurate decision there. But it could use you could choose this software to try your model, your scenario, your supply chain configuration when faced the bull effect and ripple effect. Also interesting about that. But I think I need to learn more about some of the theoretical or anything first. Yeah, but I'll have to discuss about this, the bull effect and ripple effect. And I think Pak Wira here has also have a very knowledge about this aspect. Okay, that's what can we do in Anylogistix, and the logic with Anylogistix is very simple, and then a lot of things you can do. Maybe it will be help your thesis, because yeah, there's a lot of it can do in this software. Some of problem example that that can be solved using Anylogistix is: where are the best location for our warehouse, distribution center, and production sites? We will start today. We will do some demos today. Yeah, how to allocate demand and supply in complex network. That's when we are create the network design using network optimization in Anylogistix. What are the best policies for replenishment, sourcing, and transportation? We could try it. We could use a try and error approach, or you could use some experimental design, maybe to learn more about when you're changing all this policy, how many it will be affect on your supply chain, because supply chain has many different types, because there's a lot of characteristics, a lot of different product, food and beverage, fashion, FMCG, healthcare, medicine, or anything. There's require a lot, require different approach in supply chain, maybe different constraint, maybe different situation, maybe different configuration or anything. Yeah, it will be also change your policy. You couldn't use the policy in the food and beverage, in the fashion industry, because there's a lot of different things you have to consider. So let's make me believe this is a so bigger and complex area to study, but I love that there's a lot of possibility for me to learn. I'm very curious about everything in this area. And 4, how resilient our supply chain to supplier disruption when the ripple effect is happening. What will happen if we change? Sorry. What will happen if we change our inventory policy? We could check it. How it will be affect our performance when we are decide to change the quantity of our inventory. Maybe the surface level will be down, will be decreased, but maybe we could save some money or anything. how much, which point the service level that we could decrease that not affect uh, the satisfaction of our customer. Yeah, maybe we could change about our safety stock, the quantity of our safety stock, because inventory is some of the unmoved assets. Yeah, that we have to decrease to bring down our logistical costs. And then what will happen if we change distribution centers capacity? It will be one of the demos today when the factory has their capacity constraint, and then they cannot provide all of the demand. So we have to open another factory maybe to provide the demand. Or maybe we have to create a lot of inventory. So we have to change our inventory capacity to provide that. Anything change will be affect our supply chain performance. But what the solution that's much better we have to take? Do we need to create another path, create another connection with the factory, or do we need to increase our inventory? Yeah. Which one has a less negative impact to your performance? You need to know about that. Okay, what will happen if demand change? What will happen if demand change? Do our supply chain is ready enough to when this happened? When suddenly the demand increase. I have last a couple of weeks, I have a discussion with one of the startup. They are in the early stage of their business, just launched in September. And then they are faced this condition, the demand suddenly changed. The increase of demand is suddenly changed. And then they don't have a luxury team that the team is only consists of people that got good in results, not good in product development. They don't have people in logistics and supply chain to provide them insight. They need a good production plan. They need supply chain coordination to make to face the change suddenly in demand. Yeah, I think I could help. Unless I could help them, I could make the production plan from them, and then we can change. We can check also how could a current condition to face the change on their demand, because they have a limited budget, they have a limited capital, so they are still in process to increase that. But how they are handle the current condition? Could the current condition have a compatibility with the change in demand? We could also calculate that. Okay, maybe you will lose something, but I think the current condition will have a good performance until maybe 70-80% or anything. We can use that. We can use these tools to analyze that. And then what will happen if we add a new product to the market, to our configuration? What does an out of stock even cost? How much it will be cost our profit? It will affect our profit. It will be shown it will be shown in the demonstration there. Okay, so, we already talked about the model logic with Anylogistix, but this is actual more specific logic process. We have GFA here. And then from GFA, so, okay, I'm sorry. We have GFA here as first part. If your problem need to location allocation, it's part of location allocation problem. So you need to decide where's facility have to build. You can use first GFA, and then from the GFA, you could use the network optimization, right, to create network design. And then you count out the inventory policy supplier and his sourcing to analyze the simulation and analyze the network simulation. And then you could add more information. Then you could check the holistic simulation process. Okay. I'm sorry. Okay. Yeah. And then we are moved to our demo session. Mr. Well, could I take a break like 5 minutes here because
Sure. You
okay.
can have a break. I think you can take some water breaks and stuff. Well,
Okay.
anyway, everyone. So I guess like what Pak Aji has been mentioned earlier, basically it's the theory related to network designs and how we can solve network design problems. And there are several typical network design problems, including either you want to um, decides where the facility location first, and then later on you can decide how would you create the distribution networks, or you can do it like in parallel, deciding the location as well as the distribution networks. And maybe you didn't see several mathematical formulations earlier. So that's because if you utilize software like Anylogistix or other similar software, those formulations were hidden from you because they put it in each of the module that they develop in the software. So basically, you just need to give the software the input data. For example, okay, if you want to create an efficient supply chain networks for a particular products, let's say retails products, for example, water bottle products. So this can be utilized by your end customer in several places. Then you want to decide, okay, maybe I need to have a distribution center to help the distributions for these water bottle products more efficient. Because if you ship directly from the sources, the cost might be quite high, and then later on the demand of these water bottles, okay, we know it's constant, but your productions can only, let's say, produce a certain amount of capacity. So you need to divide the distribution into several batch, right? But the demand maybe no need, they don't need to have that amount of products at certain amount of time. So you can hold the inventory in your distribution center. That's another consideration you can do. Then with this information you have, how could you determine where should I determine the distribution center, and how many distribution center were necessary to serve all my customers? Okay, this type of problem is a typical supply chain network design problems. And then what we study in in the class is that, okay, I need to select the proper mathematical formulations, and then I solve those mathematical formulation using either Excel or Excel solver or AMPL that we learn in the class. But sometimes it will be too complex if we model it until the very much detail of it. Let's say like we consider, okay, let's say if we want to consider vehicle speed in our decision, vehicle speeds will let's say associated what kind of transportation mode we are going to use, for example, like that. So that would add some complexity on your mathematical formulation, isn't it? However, some tools like Anylogistix can help you to simplify it because you don't really have to model those mathematical formulation, but instead you can use the feature in their software so that you can easily drag and drop and then choose the constraint, the considerations that you want to make for the decision in the supply chain network. Then voila, you finish, then click solve, and then you get the result. I think that's kind of luxury you can use right now when you able to harness the knowledge of using this particular software. But of course, there is pro and cons. Maybe later on we can discuss about it. But right now, let's see how easily we can set up a solution for network design problems using any logistics. Okay. So, Pak Haji, are you ready to continue to the demo?
Okay. Okay, thank
Okay.
you.
Okay, we can move on. Please
Okay.
continue.
I think that we are finished. We are not finished. We are end here. I'm sorry. Okay. First of all, we already designed. We're in the phase 4 right now. Oh, we want to create our network distribution. We already set our configuration and things. And today I'm going to show you about 3 features in Anylogistix. First of all, we are going to use the greenfield analysis to pick a best location for our facility. The objective of greenfield analysis is to determine the best location for our distribution center. We want to find the location that allow us to fulfill our customer demand at the lowest total transportation cost possible. Like I said, it's very similar with the center of gravity method. Maybe you already learned with using solve it using Excel solver. And if you are talk about the problem in supply chain, and then about creating model in logistics, there's a level of detail that divide every aspect in supply chain problem. Also about our approach. First of all, with high abstraction and less detail, it is part of we start here. This is a part of the facility location and GFA analysis. It only has a detailed information about location, flows, linear location of our customers, maybe our suppliers, and then we have to decide the best location for our distribution center. I'm sorry. And then where to build our distribution center, well, to stock master planning and fleet size estimation or anything. This is in highest abstraction, but less detail. It's very static. And then move on to the deepest level. You need to have low abstraction and more details about data, because it will be very dynamic, because in the deepest level you could use a simulation. You need a lot of data, a lot of information to create your own scenario. Okay. This is our case study that will help us to guide, to help us to know about the assumption and limitation of this scenario. It will be very simple. Okay, I will. In this case study, we met the company named a Polar Bear Bicycle and has been newly funded as an e-commerce startup selling bicycle. Polar Bear's portfolio includes 4 different types of bicycle. So we know from this case study, we have 4 types of product: X-Cross, urban, all-terrain, and tour bicycle. Polar Bear needs to find a good location for new distribution center, or DZ. First, they estimate customer demand, and so they have the data. And Polar Bear distribute their bicycle to 4 locations throughout Germany: Cologne, Cologne, Bremen, Frankfurt, and Stuttgart. And table 1 shows customer demand, which is equal to 245 bicycles per day. And Polar Bear Bicycle has hired a consulting firm to analyze supply and distribution network alternatives and to develop a best scenario for Polar Bear Bicycle. There are charts with conducting a GFA to determine the possible location of new DZ in Germany, as well as a network optimization to compare several options for network paths. The consulting firm was also asked to run simulation to validate several KPIs and plan inventory and conduct sensitivity analysis to verify all results as well. Maybe we don't we don't move until the sensitivity analysis, but we're gonna use simulation to validate several KPIs and plan inventory. Okay, this is the case study. This is the data. And then let's go move to the software first. Okay, when you download it and install it in your laptop or computer and open it, it will be like this. This is the welcome screen of Anylogistix software. Here you could create a new scenario, or you could get some information, help, and tutorials to help you understand how to running this software. Also, you could download the textbooks, some of materials, and some of even the case study I download from this textbook. So this is open source that we could use to learn, starting to learn this software, and then how the supply chain work using the software. Also, you could also read some white papers here. You could watch some videos, training even, and some case study maybe. Also here, you could also learn from the example that they provide. If you go, if you like, I will give an example. If you, this is very interesting one. Okay, if you click it, it will be open the scenario, and then it already, you could see here, this is the scenario that I clicked before. It's part of simulation. I'm sorry, maybe I will show you what is the meaning of this word. GFA means greenfield analysis, NO means network optimization, and simulation means simulation. TO means transportation optimization, right? So I click one of the feature. This Anylogistix has a 4 feature here: greenfield analysis, NO, and simulation, also transportation optimization. Here you could see, this is one of my projects with Papira, I think. Here some example of vehicle capacity, vehicle routing, and the result. Right. Okay, we are end up here. Before this is a simulation. You already, when you click the example, you could see there's some tables, some of information to develop the scenario. There's customer, their DC, their demand, facility expense, expenses groups, inventory, location, path, periods, product, shipping, and anything. This is what Pak Wira said before. It's model development, it has a mathematic, but hidden from you. You only give them the information, they will be built for you. This software will be built for you. It will be built for you. You only to make sure the information is correct, all the specification about the unit, about the parameter is correct, only that. And then you could use this experiment. In simulation, you have a simulation, variation, computation, risk analysis, and some external table. I will show you how the simulation work in here. This is the luxury of doesn't have to build a, a complex. It's actually complex, but you didn't build it. You let the software build it for you. But you need the good sense of analysis here. What it happened in the next a few minutes. It's like a discrete event simulation, right? It's starting from here, from supplier to distribution center to the customer. You could see the expected lead time. You could see here the table of utilization. You could provide lead time or anything. It's available inventory or anything. This is part of simulation. Okay, I think I'm going to too long to just give an example. Let's back to our topic of the polar bear company. Okay, I will show you some of process in starting to develop this to solve the case study. Okay. Maybe we could create scenario to give an example. So I think you can like this. Okay, sorry. Okay, food analysis. Okay, this is a starting point. We have maps here. We have some tables information here that we have to create. And then we have to input from the case study. Okay. Pak Wira, is there have problem if I make a screen, I spare the screen like this?
I think that would be too small to see on the second
okay.
one. Maybe you can back and forth
Okay.
from the slides to the
Okay.
yeah.
Okay.
Yeah, okay, like this now.
Okay, like this. Okay. Yeah. Say okay. Score first because I need to copy paste here. Yeah, maybe we could back and forth. The first information we have here, there are 4 types of product. Okay. So we could use this first of all, there's we could change the unit. So we have the 4 product. The first product here, we name it similar with the case study. You could even use copy paste here. X cross is first product, and then the second product is urban here. Okay, and the third one is all terrain here. Okay, and then the last one is tour. Okay, this is very simple. Just drag and drop and then copy paste. And also you could use this to make a similar. You have to match, but you have to make sure the unit is the same between them. We have already setting our product. It's very simple. You don't have to create anything like a complex mathematical problem. But like Pawira said, there's a trade-off because you have the limitation here. You have a luxury to didn't make a mathematical problem. The negative side, it's you could only create a model that the software provide. Okay, maybe it will be when you are face a more difficult problem like create closed loop supply chain, reverse supply chain, and anything, and that this software that still doesn't develop to the point that you could use some of cost policy and create the reverse supply chain. That's the limitation, and that's the negative aspect of using software like this. But if you create with the mathematical modeling, maybe you have the flexibility, you starting from the scratch, but there's no limitation, right? You could create the mathematical model as long as you understand how to create it, and then you can validate the process in them. But this is with the product, with the program like this or software like this, there's a limitation. But it provide a lot, very a lot of things that we could use here. Okay. This is the periods we have here, product. And then next, we have the location of our customer. We have a 4 location of customer all in Germany. I like this part. So we have 4, and then we must add 4 here. Okay. In this customer information, you have a name it and what type of customer. This is okay. This is will have a type means their behavior. Their behavior, because it's Anylogistix, it can be have extends to create new behavior, and then you can change the type of customer. For example, it's only provide 2 in the personal learning edition, but you could also create your own type of customer. Maybe there are customer risk averse or anything type of customer that you can create here. But today we only use what this software provides. Okay. Okay, you could also remove it like this. Also remove it or you could also create one again. And then next, it's a customer location. If you are create a new customer in the maps, it will be create in the center of the maps. It will be random. It could be in here, mostly in here. Okay. So we have to move their location. And then when you open the table of location, you will be drag here. Okay, maybe I have to change the name of the customer first to make sure it will be represent a real case. We could use this. Okay. Okay, you could choose this. I really have a bad habit with typo, so I will be very careful about this. So it will be changed here. No. What we have to do next is we need to change the location to represent there in the process of maybe in the process of transportation, allocation problem. This is when you create the matrix for the location. But in Anylogistix, it's very simple. You can move it using their feature like this. When you have a city in Cologne and Germany, and then you autofill it, it will be moved here. It's very simple. You don't have to. You can use latitude, longitude, or maybe you don't have any information about latitude, longitude. You could use information like where's the city, where's the region, where's the country, even where's the address that you want to move the location of your customers. So we can change all of it at the same time. All right. Okay, and then you just autofill the coordination, all of that, and then it will be both. Okay, one of it. Say I have a problem with the Bremen location, Frankfurt, Stuttgart. Yeah. Okay. Okay, the Frankfurt one have to be missed here. Okay, there's move to the exact location that I need. Okay, that's all. There's first addition and how to develop using Anylogistix. It's very simple. In the mathematical model, this process when you are creating the matrix and their location and then their distance here using magnitude and latitude. But in this process, you can you must you already have a difference in the time of a calculation. You can save a lot here, right? Okay, maybe I will move to the scanner that I already made for this calculation. Yeah, because from the case study, we know we have a 4 type of product, and we know have the 4 customer located in city in Germany. And then we also has this data, every type, every customer has a demand per day, demand per for each product, and then that's why we need a demand scenario here. For colon or terrain, we could use a periodic demand because in information the demand is periodically, yeah, demand per day. So we could use this parameter. Demand type is periodic demand, but you could also change it into the historical demand, or you can choose to create a new extension and then you can use a forecasting. But historic demand is also, you can use it as a forecasting. If you have already forecast for 1 year, you could just click historical demand here, and then you could date here and what quantity for every day in a weekly basis, in the monthly basis, yearly basis, is up to you. You could use your information already from the other process, maybe in the forecasting process, and then you are submit it into this, or you input it into this information of software to create the more information you need. Okay. But for today, we're gonna order interval using periodic demand. With order interval, it's 1, because per days is order interval days is only 1. The quantity is each days it will be asked for 15 from this city. It's starting from first day. Okay. We already decide the location here. We already have a 4 product, this period, and customer location. And the next thing we have to do is to find the best location in this process. Okay, maybe I will delete now. This is the result that I tried before this class to make sure that I still has okay. In this experiment, you have some option here. You could find the facility based on the number of sites. You could create 1, 2, 3 until 4, until 4 maybe, because if you are create 4 facility, it will be it will be uh uh I'm sorry. I'm sorry, my daughter just louder background. Okay. Sorry. Okay, we could decide the number of sites for this solve problem, or you could use a surface distance here. Surface distance here, how maximum coverage for each facility that can maximum to reach the customers. You could add like 5 kilometer, 10 kilometer, 15 kilometer, or anything. So you could just, it will be give a different solution here. But for today, maybe we will just only one number of sets, only one. And then this step of statistic, rather than explain, I will show you the difference when we are changing these parameters. And then supplier sites transportation discount, because we don't have a supplier. I have some condition when we have a supplier, but I will explain in the next part. It will be it will be affect our solution when we have a supplier, and then supplier give zero, mean he doesn't give, it doesn't give a discount. 100%, it give 100 discount, means when we are created our distribution center or worker facility, and we have a supplier here, we just don't consider the location of customer, but also the location of our supplier. Okay, but for this part, I think that I will running. Okay, how to screenshot? Okay, our running here, and then we got the result for one best product, one best facility that can provide all the customer. This is the information. We also have information about the flow, the period of product, how many product for, because the period is start from, you can see that, because the period start from January 1, 2021 until 31 December. In 1 year, this result will be calculated in 1 year. Okay. This is the flow cost estimation using pieces and kilometer distance, and how many pieces distribute from the distribution center to the customers. Okay, we got a latitude and longitude for this new type of distribution center here. And then maybe the distance demand. How many percentage demand can fulfill, and how the distance between the facility provide the demand and the location of customers. And demand of by distance, this is what we are distance step for statistic. If I change it to 50, yeah, demand by distance will be show the fraction of the, no, it will be divided by 50. Okay, you know what I mean? And then when we are changing into 10, it will be show us the different result. Maybe like this, it will be start from 10, 20, multiple by it. Okay, and then the demand presentation can be fulfilled start in 50. Okay, or maybe you want some more specific information, the distance can be changed to the 1, and it will be show you the result from 1, 2, 3, 4. Where is the percentage demand start? It's not start from 50. Actually, it start from 44. So the first location customer that very near with the distribution center is just 44 kilometers from distribution center. Okay, that's how you are handle the experiment. You could change the experiments. You can use the experiments, changing the number to have the information to help you to get information. Maybe I will start in 60, and then I try to create the surface distance. We know the nearest location of customer from the facility is 44. What happened when we are make a surface distance just 40? Distance statistic. Okay, oh sorry, this is not, must be less than. Okay, this is another information. Distance step statistic, if you are trying to surface distance, it has to be less than this, the surface distance. Okay, because it give information what the surface distance. Yeah, we are know the nearest is 44, so it will be make a 4 facility if we are create experiment with surface distance only coverage maximum 40. Okay, but what happened when we are create like 80 coverage? Yeah, it will be make a three facility that has the maximum coverage area. It's 80 kilometer. That's how you use uh GFA. Another example here is when you are changing the supplier side, supplier to site transportation discount. Okay, in this model, in this condition, I add some information about the supplier here. The supplier here. Okay, maybe I will delete the result before. I have supplier here. I added information about the supplier here. Okay, we have supplier right now. Okay, we have another distribution center side that already built existing facility. And then what happen when we are changing supplier side information? When we are give only 10 discount, yeah, the new site will be nearest, I think it's nearest here, near here. It will be nearest to the supplier, right? Because supplier is more oh yeah, because we are give the discount is very less than so we are consider the transportation cost. So it's more to be benefit use direct shipping from the customer to the from the supplier to the customer. But when we are at the discount to the point that we already, yeah, there's will be so supplier transportation will be not considered anymore. Okay, it will be not considered anymore. So we could penetrate more to make a facility near to the customer. That's when that's happen when you are create a more experiment with the supplier and transportation discount from the supplier. Maybe this will be, I don't know, in your class, but the basic center of gravity during consideration is only consider about the customer and then their demand and the distance. But GFA already also consider the supply aspect of this model. Okay, this is the simple things on this Anylogistix software. We already have a result here. Yeah, this is because the case study only need one new facility, one new distribution center facility. So it give us the best new facility in here. Okay, it's only there's your location allocation problem solved. And the next things, we move to the second part of this case study. Supply chain is okay. I'm sorry. This one. After selling the bicycle from the newly established DC, according to the GFA results, Polar Bear decided to produce their own bicycle. Okay, their production facility has now been established in Nuremberg, and 250 bikes are produced each day. Recently, they have received an offer from the Polish production factory to rent a DC in the Czech Republic at the reasonable price. The same company also wants to offer them rental of factory in Poland, even though they already have one factory in Germany. Polar Bear must now decide which supply chain design is more profitable. Okay, we have to decide a network supply chain design that more profitable here. The aim of NO is to determine which the network design optimal based on Polar Bear selecting KPIs. Therefore, the factory in Poland, the DC in the Czech Republic, and the DC in the STEM region were added as input to the model along with the Nuremberg factory. To enable the model's calculation, the reality of the case must be simplified. All demands are assumed to be deterministic in this case study without any uncertain fluctuation. They define the stage and or problem transportation between factories and DCs and between DCs customer. From a mathematical perspective, several parameters must be input as the data. This is the data that we are gonna use in network optimization problem. Okay, already make it, but I want to show you how we could also doing this in the software. Result from GFA can be converted to become the base scenario in the network optimization. So we already have the result from here. We could move it from GFA as a result to the network optimization here to make a base of it. And then we are just add some DC factories, new demand, group, location, objective, new path between them, and anything. This is the, I will shorten our time. This is our new scenario. We still have a 4 customer here, but now we have a DC here. Our result from GFA, we consider it as a DC in the same agent. We also has an opportunity in the Czech Republic for DC. We have a Nuremberg in Germany for factory that this case study has initially opened, and then there also has given an opportunity from factory in Poland. Poland, in some factory in Germany, and then I think that's already in the process to create the network distribution here. Okay, we already has all the scenario, demand still the same, but we have a revenue here from every unit that sell, and then we have a penalty if demand cannot be fulfilled. Okay, and we have the facility here. Okay, there's a question. Evaluation from the okay. Facility here, we have information about their carrying costs, about their other costs. It means their fixed costs, I think. Yeah, their fixed costs when they are running the facility, and then their inventory costs, information for per piece they are carrying, and then they have a still location here already very good. This is the objective. This is the revenue, total revenue minus its objective function in a mathematical problem. Yeah, we want to try to maximize or minimize anything, make multi-objective or anything. Yeah, you even could add some expression here. It's just not total inbound cost, total other costs, total outbound, total penalties, total production, carrying costs, supply costs, transportation costs. There's a lot of things you could use as an expression, and then you could decide the path between this. If I does the path is the connection that possible. It's still not decided in the result. It's still in the early stage that all the factory can provide to all disease, and all disease can provide to all customers. Okay, you have the processing process. This is for outbound shipment, and then for inbound shipment. This is processed in DC especially. Product flow, product storage here, and then production. This production is for cost. You could use bomb tree here to make every product a very complex that you can consider element of production plan, element of material requirement planning here. If you have a multiple supplier here to make it more complex, but in the simple manner, in the process and development scenario. Okay, you have a vehicle type. This capacity is 80 and speed is 80. What is the interesting things? You could change the value to make it with some of statistical distribution to make it more stochastic. Maybe the speed of the truck, it can be expressed in a normal distribution. Also, it's for demand can also be changed right here. For the quantity, it will be expressed in maybe exponential, normal distribution, or anything to make it more stochastic in the process. So in the day one, there will be something, but it will be changed in the day two or anything. Okay, that's a consideration, all consideration that we could use for the make a scenario to the second part of the case study. Next one, we will we move to the experiment. You can select, even you can select the variation that will be happen in the demand. It will be changed it, or we can use the exact demand. Now in the select search type of and best solution, you could choose find and best, or you can choose a solution for. If you pick and best, you could ask the software to provide you with how many and solution you want. You could say 3, 2, or 1 only. If you only want, you can use a solution pool like this. Okay, I will delete this one first, so it will be not confusion. See the result. If you are picked the solution tool pool, it will be only provide one solution. Okay, they are already calculated, and then we could see the result here. Okay, the best solution is we are open the factory in Poland and then use the distribution center in Czech Republic here. This is the best solution. This with the profit, maximum profit that this software predict is 26 million somethings. Okay, you could see the flow details. You could see the initial, which sites that new state it's closed or open here. You can see the working sites for every cost. This is the information you have to learn. You have to analyze. I'm sorry. Okay, demand, vehicle flow. Okay, name, expression, objective member, overall stats. This could happen. The best solution is make outside the area in Germany, and just pick Poland and facility in Czech Republic because the transportation cost is less than effect than the cost per day to running factory in Poland. Different in if we are decide to open in Nuremberg is just is three times less than in Nuremberg here. You could see here. Okay, also the cost for running distribution center in the Czech Republic is also 3 times less than in the Germany here. See here. Carrying cost is also more cheaper in Czech Republic. And then it even though the transportation cost maybe much higher if you are pick the route just far away from our customer, but because the facility and inventory cost is more cheaper here, and then when it calculated, yeah, the best solution is we have to pick in outside the Germany things. And that's how that's the result. And when what happened when I changed it to not solution pool but find n best, and I input 3, it will be provide us with the 3 best solution here. This is the 3 best solution for iteration 1 is exactly the same like solution before, and section 2 is just like this. Now, what is the difference between this one with this? Because we are push this software to create 3 solutions, then in the iteration 3, he pushed to consider facility and STEMO agent, but they don't use it to in the network distribution because we are pushed. And then we are conclude that the best solution is only 2 here. Right? It's using STEMO agent as distribution center and Poland for it, or use the Czech Republic distribution center and still use Poland for it. Okay, because all the logistical cost is very low at this, and it will give a profit much better in here. Okay. All of that information and the process of network distribution, so we already we know how it ends. We are using Poland factory here, and then using Czech Republic here. We're going to use this route to create a distribution network to our end customer here. Okay, so we have our network design using NO, but we are not done yet. And then the optimization results show that the highest profit can be achieved in the supply chain design with a DC in Czech Republic and factory in Poland. However, the negotiation with the factory in Poland revealed another constraint. The Polish factory will only consider annual quantity of each type bicycle within the range of 10,000 units, minimum capacity utilization until 2,000 at 25,000 units for maximum capacity. So Polar must now conducting another NO to include this additional capacity constraint. So now we have another constraint to consider. Okay, so already here, okay, in the okay, in this production, no, we have another constraint that the Poland have the minimum throughput is 10,000 and maximum throughput is 25,000. We can add it for every types of product. We can next we could calculate it, which okay, I think I will find solution only solution pool here. what is the best solution if we are try to add some constraints consideration. You could see here profit is down because, well, we are pushed because the new constraint is arrived. We are pushed to make another decision. This factory couldn't provide for all customer needs here, so we are pushed to make open the factory facility in Nuremberg here. Okay, that's if I back to the hour as our discussion in the first in early you could see how affect the capacity will be affect our network design. It's not only about this logistical cost, not only about a facility, about transportation, but also about how inventory and capacity will be affect our decision process. Okay, see, we are, because a new constraint arrive, we are supposed to make another decision, and the best decision from iteration 1 is like this. Okay, you could also analyze why it become like that, because maybe the number of process production flow, it will be limited here, so we have to okay, look at this. There's a maximum here in the Poland for urban and tour. We cannot exceed the 25,000. So we have to open the number for only the tour and urban to fulfill the demand that can be produced in the Poland. Okay, that's why we open new product to fulfill. We open new factory to fulfill the customer demands. Okay, that's a signal when the solution change. Next, okay, if you have a question, just raise your hand. Okay. Next, we are moving to the third part of this case study. I'm sorry. We are moved to supply chain simulation for polar bear simulation, supply chain design. In a simulation, we extend our analysis by adding the following feature. We introduce the inventory control to manage ordering process. We introduce sourcing policy to manage replenishment process, and we introduce a segment control, LTL and FTL, to manage shipment process. First, we simulate the supply chain with the factories in Poland, and then we are adding this information to the simulation. This is, I think, we could say this is the first policy they are made. Maybe they are make mistake with the policy, but like before, we could move this result. Yeah, I'm sorry. Why? Okay, from this result, okay, we got the iteration. What we could move this result to convert to the simulation, to the GFA, to the TO scenario. So we already have this. We could move it to the simulation part, and then you have this. You have the NO level constraint in the simulation right now. Okay, maybe I will skip that part, and then you could see this. I already use another information here for inventory. The inventory policy is using min-max policy, but yeah, we will find out soon. This is not a best policy for this. Okay. Yeah, production time, I think they're randomly designed. Okay, 0.5. unit per days or anything like that. Expected lead time from the customer is 5. Okay, I want my product in my at my house in 5 days, like that, something like that. And then sourcing policy cost is dynamic and transportation policy is less than transport. Okay, you could see this in the processing production. Yeah, you have a new parameter here for production for every type of product. Unbound sourcing process dynamic, and then in the path, I think we are decided to using sorry, not in the parts, maybe we see shipping. In the shipping, we are using policy of LTL here. Okay, let's see how it will be affect our performance in supply chain in terms of in simulation, day-to-day basis, product statistic, and then we could running, and you could see the process of our supply chain here. This is a table and graphic that you can choose from this product. You could see the revenue, total cost, transportation. Here you could see the average daily available inventory and product unit. It's keep growing, and then expected lead time service level by the product, it's keep decreasing. You have to know, this is good or bad for your supply chain. This is bad for your supply chain because expected lead time service, it keep decreasing right now. And then lead time, you could see it happens. There's some lead time, it's more than 41 days here. This is very bad, and production utilization is very high. And then the backlog, demand backlog, it's keep growing. So you could see there are a demand that cannot be fulfilled on time here. This is the bad performance because available inventory keep growing here, and then profit is minus. Profit is minus. This is one of a signal that you made a bad decision, and in terms of creating inventory policy, sourcings, and transportation. Okay, but you need to, this is another part you need. It's very easy to create the model, the scenario, but you have to sharpen your sense and knowledge to analyze this, to read this. Okay. Yeah, I think we can pause it and then back to the simulation. I think we already know there's a bad signal about the performance of our supply chain in daily basis. And then manager and Power BI also admin that. So they are changed the inventory policy. Why? One of the reasons they failed in their supply chain performance is they are not considered their different demand for every product. You can see from Cone is urban it's more popular than X-Cross. In Bremen, it's also urban. It's more popular in X-Cross. But in Frankfurt, X-Cross is more popular than any other types of product. And in Stuttgart, the Tour is more popular. But when they are create the inventory control, they are set it same for all. Inventory policy same for all. I think that's when they are pick the wrong path here. So they adjust their supply chain policy, the inventory, they adjust it for X-Cross, for urban, factory in Germany, become there's a higher set of inventory policy, and then they are producing more faster than before, and they are changing all of their policy to to make it more fit and fit for compatibility for their demand for customer. And then we could see what happened here when they are change it. All right. Okay, I will delete this one. Okay, when they are change it, terminate and process. Okay. When they are change, sorry. I have to show you what they are changing. The inventory control. They are changing, and also the production time for every, it's now different. They are more focused for the most popular product here. And when we are running this next simulation, we could see here the average daily inventory is not more than 80. You could see 500 before, right? Then expected lead time is over fulfillment time. It 100. And then lead time is not more than 2 days. There is no 41 here again, and the product utilization, it's keep under 1.8 here. So the balance is happened, and there are no demand for product backlog here. So there's not only you already made location allocation planning, and then you also create the network optimization here. You also help this company to create their policy for day-to-day or daily basis for inventory and transportation, sourcing, or anything. All of that is part of supply chain, and they're very complex. And when you are you could create it in another simulation tools or using mathematical modeling for the start process, but see how fast it's until this stage, right? How many times that you can save to find all the solution, all this insight that you can provide to the industry. It's very fast. Yeah. It gives you a lot of easy process, but you need to understand all of this. Okay, the profit, it's not negative anymore. The expected time is still good here. Still, there's no backlog process and anything. Okay, even I could give you, you could see there is only 4 KPI that we are monitoring here, but using Anylogistix, you could add more statistical or KPI. For finance, you could see from average cost per item, average cost per order, facility cost, inbound process, until the transportation cost. For distance, travel distance, for product, KPI for product, available inventory including backlog or anything. You could even evaluate your supply chain performance using these apps. And for academia, this is all the good insights. What happened when we are changing our policy to the lead time? What happened when we are changing our policy to the service level by orders? There will be trade-off in that or not. Okay, there's a lot of things for orders, for cash to serve. Okay, for CO emission, others, anything. You could use that all information to provide industry for all the alternatives here, so they can make a confidence decision. Okay. I think with a lot of information like this, we could be very confident in the process to make to our decision. We could say for sure we move to option 1 using all kind of this policy in our supply chain. Okay, that's all from me. Thanks, Pak Wira. Okay, this is for reference. I think I suggest you read books from Sunil Chopra. Dmitry Ivanov is very brilliant man. I think from here. Oh, I think provide a wrong reference. I will correct it. Okay, that's all from my side, Pawira. Thank you very much.
Okay. It is a very nice sharing session from Paji. I think I will stop the recording here before we start the discussion.